My name is Itzhak Gilboa, and I'm generally, I would say, mostly decision theory. That's my field. It's a field that basically has two kind of academic markets, I would call it, that we try to sell our merchandise to. One is the economics one, the other one is more the business management, where the distinction is very much along the lines of whether we're only trying to describe behavior or also trying to change it. Where in business schools, management, etc., then you talk to students who say, how do I become a better decision maker? What can I do? And then presumably you could, using knowledge about what they do and what they could be doing, you could try to convince them that they could be making better decisions in their own eyes. At least that's the way I like to think about it. And certainly the way the students like to think about it. They don't want to buy your authority. The economics market is different for the most part. It is just describing people's behavior. In economics, we do distinguish between positive descriptive economics and normative. But even when we do normative economics and we try to ask what is the right thing for society or the economy or how should the government achieve something, usually we don't change behavior, don't assume we can change behavior at the individual level. So if I think about what's the right taxation policy, then I can think about certain goal for the economy. Usually I would not assume that I can go to any individual decision maker and tell them, don't smoke or something like that. I might affect the price of tobacco in the hope of making them smoke less or something. So here decision theory is much more on the descriptive side. Both sides of these have what we do a lot is the axiomatic approach. And the axiomatic approach is trying to look at decision modes and trying to say what are the kind of properties they satisfy and what kind of properties would identify them and say, well, if you behave in this way, then you must be obeying this kind of model. The axiomatic approach is very, very beautiful and very enticing. And generally, I devoted most of my life to it. So it's there's a beauty there that some of it comes from the mathematics and from the conceptual, philosophical side, in the sense that it gives meaning to concepts that could otherwise be very let's say, vague up to metaphysical things such as, what is utility, what is probability. And one thing that really attracted me to the field is that it gives concrete meaning to these things by saying, well, if something behaves in a certain way, you could describe it in a certain way. So one thing that I like about it is that it's very non-metaphysical in this sense, which I took me years to understand that I was incapable of understanding metaphysics when I tried. But one thing that is really beautiful about it is that it gives concrete meaning to these concepts. So I'd say that in economics, we generally adopted this approach, which I think Wittgenstein is probably the one we most owe to, in the sense of not asking what, but asking how, in the sense of asking what is utility or what is probability is not the right way to pose it, but how do we use it? And if I know how you use it, I know what it means. I mean, the concept does not have a meaning beyond the way it is used. And that's basically what's behind the axiomatic approach. So I think it draws on logical positivism in the turn of the century and the general idea that came to economics as revealed preference in the 30s is to say, well, I really want to know how this is reflected, whatever it is that you think is going on, how it is reflected in economic behavior. Define to me what are your data, economic choices or things like this, and these are the things you're allowed to play with. So the axiomatic approach is basically asking what kind of decision modes can be identified by certain behaviors, or what kind of concepts such as utility, probability can be defined by these things. So it's very beautiful and very profound in many ways. And sometimes, you look at it and say, wow, it's so beautiful. Or even In particular, there's this beautiful theorem by Savage that I've been teaching for more than 30 years, but I can't fail to be excited about it, even though most of my career was about violations or generalizations thereof, but you still look at it in awe and you say, this is just so beautiful. Specifically about what I would, what my personal agenda is, and a lot of it is with David Schmeidler, who used to be my advisor in my graduate studies and been close colleague over all the decades since. When it comes to economics, the major question that's not been dealt with enough is where do beliefs come from? So we have this approach, the black box approach, that says if an agent could be a household, could be a firm, could be an individual, excuse me, if it behaves in this and that way, and then there are some what we call axioms, namely conditions of mostly of consistency. If you make this kind of decision, this setup, then you should better make this one there, and then you behave as if, and then comes a nice mathematical model, and it can give meaning to this concept we talked about, such as utility and probability. But the whole black box approach doesn't say where things are coming from. In terms of the economic history, or the history of the economic thought here, you could there are some speculations that don't always get all the approval, neither of the people who invented them nor of the economic historians. But psychology and economics used to be much closer in the 19th century. Something happened between 1900 and 1930 where psychology became, at least at that time, much more Freudian, and economics at some point decided, to the extent that a field can decided to be much more scientific, much closer to the natural sciences, to focus on observable behavior, etc. And there's been a certain rift between the two until the rise of behavioral economics in the 90s or so. A related thing is that this axiomatic approach made economics even further, not economics, but decision theory even further away from statistics. If you go back to the 1950s, then these were the same people who were doing decision theory and statistics, like Abraham Wald and people of that size, of that type and this magnitude. But the black box approach that the axiomatic one uses is saying, well, we're not getting into your mind and not asking what are your beliefs and where do they come from, just treating you as a black box, and then there exists something and I describe it from the outside, but it doesn't really give you a lot of help as a researcher to find out which beliefs people might have. And this is relevant on both sides. If I'm thinking about the normative applications, when I'm talking to, say, actual decision makers, and they say, okay, you convinced me that I want to be this kind of person, but help me become one. How do I choose my utility, my probability? We're generally silent on this as a field, as a theory. But also in economics, if we are just describing the behavior of people out there that we don't pretend we could affect, or choices or behavior, and we are just sitting here and saying, okay, how do they going to react to an economic crisis or financial crisis or something like that? And come the decision theorist and tells you, look, if you believe that they satisfy these conditions or these consistency conditions, then you actually believe that they satisfy that. Okay, so because this is what an axiomatic theorem would say, would actually reframe the theory, a theory that says, well, people maybe maximize expected utility with this belief. Doesn't sound right and doesn't seem like what you do or your neighbor does. But if I tell you, oh, you only make decisions that are consistent in this 1, 2, 3, 4 ways, and then you agree with me, and then I say, puff, here is a theorem that says that if you agreed with this, you have to agree with that. So it's sort of a framing effect, a sophisticated one that says, well, you have to buy that. Then let's say as a working economist, you should say, okay, so I agree. Then people are maximizing expected utility or something. But relative to what? Where do I get the probabilities that they out there might be using? Again, we are silent on that. So for these reasons, we think this project started mostly with David Schmeidler and continued with him and other colleagues. that more should be said about a rigorous theory of where people come up with beliefs. What kind of beliefs do they have? By which I mean that if I knew where people come up with beliefs from, then I would also know maybe when this model applies and when not. David Schmeidler started in the early 80s by challenging the Bayesian approach, and then I continued working with him on that. The Bayesian approach is the idea that any probability, any uncertainty can be quantified by probabilities. Long, wonderful, very profound debate that goes back to the very early days of probability theory, from Pascal already in his wager 1650 something, when very early days of probability at all, he already used the probability as a way to think about quantifying uncertainty, making decisions, and he had some fantastic, beautiful ideas there. But throughout these centuries, it was not clear whether any uncertainty can be quantified by probabilities. A major thing was made by Bayes, after whom the Bayesian approach is named. And Bayes, as far as I understand, his argument had to do very much with the intelligent design argument. So he was trying to prove that God existed by the basic argument that says, oh, how much of a coincidence it should have been to find the world as we find it had God not existed. Bayes was maybe not the greatest mathematicians ever, but he was not a mathematician like Laplace, who did the same thing, but he was sufficiently sophisticated not to make the mistake that that Kahneman Tversky showed that people tend to make, of confusing probability of A given B with B given A. And he realized that in order to get his argument through, he needed some prior probability on God. So the intelligent design argument that says, had God existed or not existed, in order to go through the calculation, you need to have some kind of probability on whether God exists or not. And that's obviously not a probability that you could get from frequencies or something. It has to be subjective. And he assumed something like 50-50. But from that point on, the idea that anything can be quantified is being called the Bayesian approach. It's been one approach in general, in statistics in particular, and not necessarily the most popular approach in statistics for most of the past centuries. Bayesian statistics is catching up more and more recently, but it's certainly not the dominant approach, not what we teach that. Within economics and decision theory, it caught up with these axiomatizations in the 1950s, so it was people like Ramsey and Definetti and mostly Savage, whom I mentioned, who basically convinced the field that this is the way to behave rationally. So the works that David Schmeidler started, and we've done a lot together, sort of challenged this. And part of the question is also what is rationality, and why something that seems so beautiful and convincing as Savage's axioms might not be so convincing in some other cases, because some of the implications of this seem highly counterintuitive. So a lot of the work is also on the conceptual side of trying to understand what do we mean by rationality, and why certain things that might seem very reasonable are not always so reasonable, etc. What David Schmeidler did, and I did with him, and mostly in the 80s, was work on alternative models that would allow for a non-Bayesian approach as well, namely uncertainty that cannot necessarily be quantified. And some of the work later on was on why is this rational, and why, if I think about what I want my government to do, whether it's about global warming or what the central bank is want to do I necessarily want them to be to be Bayesian or not? Which my answer is not, but part of the main argument there is that the Bayesian approach assumes that you can quantify everything and doesn't know how to say, I have no idea. And that I do not think it's more rational to pretend that you know when you don't than to admit that you don't. And the Bayesian approach does not have the language to say, I don't have the foggiest idea. So on this background, when I talk about where beliefs are coming from, so for us, it seems clear that it's not always necessarily probabilities. So the right model to use, the most rational model to use, need not necessarily be the probabilistic one. But the approach is to say, well, if we start from asking where beliefs are coming from and start to build up to that, then we'll see also whether we end up with probabilities or not. Because if we take the reasonable approaches to construct probabilities and we draw on statistical theory to the extent that we can, if we end up with probabilities, then maybe it's pretty reasonable to assume and rational for the agents to have and reasonable for me to assume as a modeler. But if, when I start working on this, I find out that there are those divergences of opinion, and even with the global warming, where basically the physics is very well understood, there are different groups that are giving different estimates of probabilities, then maybe it's more rational to admit that we don't have a point probability. And after we've used all the statistical and scientific knowledge we have, there are some things that we still cannot quantify. Then maybe we'll figure out that the rational thing is to resort to models that are not so specific or rigid in terms of having a point probability. So, so that's part of the project on the, I'd say both the, let's say the economics and the management side. On the side of the dialogue between decision makers and decision theorists, I think that there's one important message that we should be conveying is that you shouldn't look at formal models in the be-all and of the end-all be-all of theory. There is a tendency, I think, of people first mistrust theory in general. And the other thing is, okay, if I can trust it or if it can be done, then let me relegate it to someone else. I mean, people tend to be lazy and don't want to think. And then there are two ways in which you don't have to think too much about it. One is to say, okay, if you know how to do it, like if you know how to come up with the probabilities or tell me what the right decision is, let me outsource it. Let me have some programmer do it for me and do that. Or the other way to do is say, well, these models don't capture my intuition anyway, and it's no way to apply them, and I throw them out the window. In both cases, I don't have to think about them, and that's very tempting. But I think it's wrong. I think there are many situations that where you need to think about it, and the reason is that there are many situations where you cannot indeed just outsource it and have some programmer write it down and get a computer to give you the right answer. At the same time, formal models can really help you think about the problem and avoid some reasoning mistakes. So, and I think we're not probably delivering this message right, because the way that the field started, as far as I understand, is that it was much more optimistic than maybe today we would be. The idea was that we can think about decision making in a way that could be relegated to a computer. And there are some successes of that. For instance, if you think about Google Maps or Waze, it's a wonderful success. You need to get from point A to point B, and someone comes and tells you, I'll do this for you. I have a map of a city. I might even have data on traffic. You just tell me what you want to do, and I'll find the best way for you. And we have algorithms to compute the shortest path, and we have the data to collect it. And if Waze tells you to turn left and you feel like turning right, turn left, because the problem has been solved and the computer knows better. When it comes to something else, like, what should I do with my money? If students ask me what to do with the money, I say, look, how would I know? the very fact that you have money to invest already proves that you know more than I do. So how could I give you an advice? At the same time, I don't have an app like Waze that would tell you how to invest or what's going to happen next with the oil prices or something like that. At the same time, I think the formal models can be of huge help in terms of clarifying things and testing your intuition and looking for problems and potential pitfalls that we know from psychology that do exist. So I think that what's not sufficiently emphasized is the role of decision theory there as sort of a dialogue between the decision maker and the theory. Sometimes the dialogue is really the decision maker tells you what the problem is, you put it on a computer, you give them the answer, and they're supposed to obey, otherwise they're being foolish. But in most cases, it's not like that. The other extreme is that you tell me what you want to do, and I say, okay, now let's sit down together and try to build an explanation of that. We'll try to justify it post hoc. You tell me what to do because this is your gut feeling, okay? And you're the decision maker, and you probably know better. But let me just sit here with you and try to see what kind of beliefs would justify it. What kind of utility do you need to know to have? And sometimes you might be confronted with things that might not be comfortable with, such as what you really care about in terms of your utility function, and or what kind of beliefs you have that sometimes can be a bit extreme, things like that. In this context, it's not only the actual decision that's been discussed, but what decision theory can help you with is also what is the language of this dialogue. Because if we take the classical models with utilities and probabilities, and I ask you, for instance, what do you think is the probability of a war in the next 2 years? And you look at me and you say, look, I don't really know. Okay. And I don't know anyone who can come up with a number. Then I could say, okay, well, you don't like probabilities, fine. But we've been working on this for a couple of decades. And I have here another model I can pull off the shelf. It doesn't use probabilities or use probabilities in a different way. Or I have a model that doesn't even use what we call states of the world or something like that. And then the decision theoretic model that we use becomes part of the dialogue as well. And that's where I think that there's room for many decision theoretic models, and that we shouldn't be religious about any of them. And I think that one thing that we should be conveying as as a field to quote unquote humanity is that there is a lot in formal models and analytical thinking that can be helpful, even if it's not the kind of problem that you could just relegate to a computer and get the answer back. And I think it's wrong to throw away all the formal models just because you can't expect it to give you the answer the same way that Waze does. And it's ongoing dialogue, I think, is something that's very important.